Okay. You wanted to start with the quiz?
Yeah.
Okay. Oh, shoot. I almost just opened the wrong one. Okay, number 3. Find the margin of error for a 90% confidence interval when the standard deviation is 50 and the population is 25. So margin of error. I think Wanda's calling me real quick.
Oh.
Hello? Yep. Hey. What? Uh-huh. Okay, do you want to maybe watch the video later? My sound, I have to wear headphones is the problem. You can try calling Myra if she, I just don't know, like if you can't open the quiz or. Oh, okay. Gotcha. Okay. Yeah, I can try. I just, let me see if I can plug my phone in. Okay. Speaker.
Thank you.
Yeah. Can you hear me okay?
I can hear you okay.
Okay. So we're in the quiz on number 3. We just started.
Okay, I'm going to open it up right now.
Can you hear me, Myra?
Yes.
Okay.
L10 group meeting quiz.
Mm-hmm.
Opening it up. Yeah, I even brought my laptop here and okay. On question 3. Opening up the applet that he said to open up. Okay. We're required to work together on the quiz. Each member of the group must submit his or her own answers to receive credit. If needed, here's a probability applet link. When calculating round 2 3 decimals. Find the margin of error for 90% confidence interval when the standard deviation is 50 and n 9. Are you guys talking?
No, we're just letting you figure it out for a second, and then we'll go over our answers. Did you get it, Myra?
No.
Do you guys need me to explain how to do it?
Oh, number 3, I already did it.
Oh, you already did. Okay. What did you get for number 3?
I got 16.45.
Okay. How did you do that one?
Well, first, 90% is it's 1.645, right?
Oh, okay.
That you have to multiply by 50 and divided by the square root of 25.
Okay. I used 0.10 on accident, but. Oh, so you got 16.45?
Yeah.
Yes,
Okay. Wanda, can you hear me?
I can.
Did you get 16.45?
Yes, got 16.45. 0.
I
round it to the third.
Yeah, but last time on the quiz, when we rounded to the third, adding the 0 was wrong. So I'm not going to add it, but. Okay, number 4. Which of the following statements is true? What?
Is Brian with us?
No, he's on a call.
Which of the following statements is true? Square is an estimator of x. X is a point estimator of mu. Mu is a point estimator of x. Mu is an estimator of standard deviation of 2. X is a point estimator of mu.
That's what I got as well. Can you hear her, Myra?
Yes.
Okay. Do you agree with that one, that number 2 is right?
Yeah.
Okay. Number 5. Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a simple random sample of size n equals 64 and computes x bar equals 526. Use the information for the next 6 questions. What is the point of estimate for the true GMAT score?
Things 526.
Let's set up the equation here. Standard deviation is 113. X is 526 and n is 64.
So for this one, do you guys use that big long equation with the lower and upper bounds?
Well, the answer is, what is the point estimator? It's going to be 526. Because you're going to take that from your answer there.
Oh, I see. Okay.
Did everybody get that?
Did you get that as well, Myra? Okay. Number 6. What is the margin of error for the 95% confidence interval for the true GMAT score?
The margin error is going to be 95%. Or
There's a formula for that one.
20, and we got to use the above information to for those down questions.
Yeah. So for that one, did you guys get 27.685?
Yes, 27.685.
Great. Did you get that as well, Myra?
Just a moment.
Oh,
Yeah.
Okay. Awesome. Number 7. What is the lower limit of this confidence interval? So for that one, did you guys get 553.685?
The lower limit would be 49.8315.
I guess 498.315.
Oh, I did the upper limit. Oh my heck, I'm so confused right now. Okay. So you minus 526, right?
Yeah.
Okay. I am turned around today. Okay, so 498.315.
Yeah.
9.8315. So we have to round it off, don't we? It's going to be 882.
No, because it's 3 decimal places, so it's 498.315.
49.8.
No, 498.315. Yeah. Okay, so then the upper limit is the 553.685.
Yeah, I got that.
553.685.
Is that what you got as well, Myra?
Yes.
Is that what you got, Wanda?
Yes.
Sweet. Okay. Number 9. What would happen to the width of the confidence interval if Gina increased the sample size? It would increase, right?
What would decrease?
Width would decrease?
Yes.
Okay. So, are you guys ready for number 10?
Moving
Yeah.
on. What
Okay.
happened to the width of confidence interval if 10 is changed into a 99 confidence interval?
It would increase as well.
increase.
Yeah. Or, oh, downloaded. Did you get that as well, Myra?
Yeah.
Okay. Number 11. Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need?
Yeah, plug in the formula.
Hello, this is Roman from Thanks for watching.
245.863.
So it will be a whole number. It will be 246.
Oh yeah, because you have to round it to a whole number.
246.
Okay. I got that as well. The mean salary of actuaries is mu equals 100,000, and the standard deviation is mu equals $36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with a level of significance alpha equals 0.05. And you collect a simple random sample of the population is 36 women's salaries and find that X bar is 111,000. Use this information for the next 3 questions. What is the lower limit of this 95% confidence interval?
Lower limit would be 9901.53.
I want to do the math too real quick. So that's why I'm not answering. What did you guys get for that one?
Rounding it up, 9900.
I got 99.001.
Because you gotta round it up to the nearest whole number.
So you guys got 99001 or 99002, I guess.
9900. I guess it would be 2 if you're rounding it up, wouldn't it?
Is that what you got as well, Myra?
Yeah, but I put 1.
Okay. If you round up, don't you move that 5 up though? Okay. So number 13, the upper limit of this confidence interval.
So are we putting 9900 or 9902?
I got 99002. That's without rounding until the very end, though. Let me make sure. Yeah, I got the same thing. Are you guys rounding before you get it, or before you, I guess, like, I don't know.
After.
That's what, so what are you guys getting?
I'm putting 99.001.
Okay. So then number 13. Did you guys get 122,998?
Yeah.
Got 1.99. Oops.
I got 122,998, no decimals.
Yeah, so.
So that one you just
put it in the applet, don't you? 95%.
oh,
and
you
round it to the nearest.
so that's how you get the if you put it in the applet, that's how you get the z in your equation. So you do 111,000 plus what you put in the applet, and you get 1.96 times your standard deviation over the square root of the population.
I got 1.996 times, because you're taking it from the previous, 37676 with a square root over 6.
Yeah, so when you compute that out, I get 122,998.
You get to round it up or whatever. You can put it 1.229. or 1.2299?
Yeah, you
Always
just
some margin of error.
just make sure you're
What
not
do we
putting
do?
that point, because it doesn't have a decimal in it. Are you getting a decimal, or are you? Do you get a decimal, Myra?
Yeah.
So what are you getting?
122.998.
So is your equation set up like this, like 111,000 plus 1.96 times 36,730 over the square root of 36?
Over 3,676.
Am I writing it down wrong?
Oh, no, I'm not getting the decimal, just the whole number.
You're getting a whole number?
Yeah. Yeah, I don't know what happened to the point there.
Okay. So what did you get then?
120,998.
Okay. So for that one, Wanda, are you still getting the decimal when you do it? So what I think, I don't know so for these, you don't have to use the applet. I don't know if you saw in the notes that little chart they gave us of like, they like give you like what the level of confidence is, and then they give you what the Z star is. So for that one, you just use like, it gives you 95% is always going to be 1.96. So you plug that into that equation. So my equation ends up looking like this. It's 111,000 plus your Z, which is 1.96, times this fraction, which is 36,730 over the square root of 36. And then you get 122,998.
What, no points in it?
No. Because when you're looking at like the problem, even like the number, the mean they're giving you is 111,000. So you're needing a number bigger than that for the upper means, if that makes sense. Or the upper bound.
Right on to the nearest whole number.
Is that making sense?
I'm going to have to do it over if I get it wrong. I forgot my calculator.
Oh, gotcha. Yeah. That would be tough to do in your head.
Hang out with 1.
It's 122,998.
12298.
No, 998.
998, and no decimals.
No.
Okay.
And then number 14. There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are a simple random sample, deviation is known, X bar is normally distributed. So those are all true.
They are all true. I concur. It won't let you. They're all above.
Yay. Did you guys get 100?
I'm going to go submit my quiz right now. Submit.
Yay.
Not letting me submit.
Oh, jeez. Like, not after all that work.
Well, thank you for going over that one question.
Yeah, no problem.
Oops,
I got 100.
I got 12 wrong.
Did you type in 99002?
I put 1299 point.
Oh no, so it's 99002. There's no point.
99002.
Do you want me to go through that one with you?
Yeah.
So it's in that big long equation they give you, like the finding the bounds or the limits. So it's X bar minus Z times the standard deviation over the square root of n. So X bar in this equation is going to be your mean, which is, let me make sure I'm doing this right real quick before I say it. Let me do it really quick, make sure I'm telling you the right thing.
I missed like 13.5. Got a 96. So I must have missed another one. I missed 13. I'll have to go over them. And I missed 8. So what did you get for 8?
For 8, I got 553.685.
That's what I got. I got a 0.5 for that. Okay.
Oh, okay, you got it then.
I was just reading the numbers wrong. The exact points. What was 0 was, I just got one wrong then. It was 12.
Yeah, so for that one, I'm going to do it really quick to make sure that I'm telling you the right thing before I say anything. So for number 12, it's just like number 13, except for the equation is going to be minus. So it'd be 111,000 minus 1.96 times the 36,730 over the square root of 36. Because on this one, you're trying to find like the lower bound. So it's going to be lower than the mean they give you. Like you want your answer to be lower than the mean they give you. And for the upper bound, your answer needs to be higher than the mean they give you. And then, so it's that equation, that big long equation that they give you. It's just the left hand part of it. Does that make sense? I'm really bad at explaining things. We need Brian here. Did that kind of make sense at all?
It does make sense if I get the equation in front of me.
Okay, do you want me to tell it to you?
Yeah.
So for the lower bound, it's x bar minus z times, this next part is a fraction, so it's the standard deviation over the square root of n.
Okay. Thank you.
Mm-hmm.
Well, you guys have a blessed night.
You too. Are you working tonight?
Yep, I'm at the hospital right now in the library because I had to be dropped off on the way from my husband's doctor's appointment
Oh.
to connect with you guys because I wouldn't have had time to go home and get things set up. He counseled me to bring my laptop, and I tried to get the Google Hangouts on my laptop here in the library, but it just kept on ringing and ringing and ringing. So.
Dang it. Well, have a good night at work.
Thank you. Yeah, but we'll see you guys on Wednesday night then.
Yep, see you Wednesday.
Okay, bye-bye.
Bye.
Bye.